Hello friends, I welcome you to my YouTube channel MacPM. So in this video we will solve a numerical problem which is based on the columns and Euler's formula. Okay, so first of all we have solved many theoretical portions and numerical problems already in this playlist. So if you are watching this video for first time, then I request you to please go to our playlist and start from video number 1. Okay, so let's read the problem. Using Euler's formula, calculate the critical stresses for a series of strut having slenderness ratio of 40, 80, 120, 160 and 200 under the following conditions. First condition is both ends are hinged and both ends are fixed. This is second condition. So first of all, what is the Euler's formula? So Euler's formula is P critical, or P critical means at which this column will fail or strut will fail. So it will be equal to P crippling load or P buckling load. Okay, and formula, Euler's formula for this is pi square E I upon L square, L effective square. Okay, now if it is given as slenderness ratio, so what is slenderness ratio? L by K, length by minimum radius of gyration. Okay, so where will get L by K? So in this equation there is no K. So how to find, how to insert K? So you know that I, moment of inertia, is equal to area into radius of gyration square. So we will just put this value in this equation. So we will get pi square E A K square by L effective square. So it will become pi square E A upon L effective divided by K square. So this is the formula for P critical or P crippling load. Okay, this is load, and if we find stress, this is critical load. Okay, critical load or crippling load or buckling load. Okay, so what is critical stress? C is equal to load divided by area, or P divided by A. So if we find critical stress, okay, so suppose critical stress is represented as sigma C, then sigma C will become PC by A. So if we divide it by A, then it will become pi square E divided by L effective divided by K square. Okay, so this is our crippling stress. Okay, I hope you understood up to here. Now there are two conditions: both ends are hinged and both ends are fixed. So if both ends are hinged, then column will be like this. Okay, and it will bend like this. If both ends are fixed, then it is like this, and it will bend like this. Okay, so in this case L effective is equal to L original length, and in this case L effective is equal to L by 2. Okay, so we will keep this in the formula. Sigma C for fixed ends or hinged ends is equal to pi square E upon L by K square, and sigma fixed and sigma critical for fixed ends will be equal to pi square E upon L divided by 2 divided by K square, which will equal to 4 pi square E upon L by K square. Okay, so from here what is given to us in the question is given as 40, 80, 120, 160, 200. This is the slenderness ratio, and slenderness ratio is L by K. So L by K is equal to 20, 40, sorry, not 20, 40, 80, 120, 40, 80, 120, 160 and 200. So for this, first we will calculate for both hinged. Okay, so for this is the formula. So we will put just L by K is equal to 40. So sigma C for 40 will become pi square E. So pi square into E divided by L by K is 40, so 40 square. So it will become pi square into E is 2.05 into 10 to the power 5. Okay. Sorry, I have missed one thing. E is given as 2.05 into 10 to the power 5 Newton per mm square. Take the value of E as this. Okay, so we have kept these values divided by 40 square. So if you will calculate it, then you will get 1264.54 Newton per mm square. This is first. Now you will get sigma C for 80. It will be equal to pi square E divided by 80 square. It will be equal to pi square into 2.05 into 10 to the power 5 divided by 80 square. So it will be equal to 316.135 Newton per mm square. So you can calculate like this for all the cases, but if you see that sigma is inversely proportional to L by K. Okay, it means if L by K increases, then sigma will decrease. Okay, so it is proportional to. So if sigma is L by K is becoming double, then sigma will become 1 by 4. Okay, so in this case L by K is tripling. Okay, so sigma will become 1 by 3 square sigma 40. This will be equal to sigma 120. Means if slenderness ratio is 120, then 40 is 3 times 120 is 3 times of 40. So slenderness ratio will become 3 times. Sorry, this is not 1 by 3 but 3 square. Okay, so it will become 1264.54 from here divided by 9, 3 square. Okay, so if you will calculate it, you will get 140.5. or if you are not comfortable with this, then you can calculate like this by keeping value of 80 now we can input 120. Now 160, if you want to get for 160, then it is 4 times. So it will become sigma 120 will become 160 will become sigma 40 divided by 4 square. Okay, because 160 is 4 times of 40, so it will become 1264.54 divided by 16. So from here you will get 79.03 Newton per mm square. Similarly, sigma 200 will be equal to sigma 40, and 200 is 5 times of 40, so it will be 5 square. So it will become 1264.54 divided by 25. So it will become 50.58 Newton per mm square. Now this is for case when both ends were hinged. Okay, Now when both the hands are fixed, then it will become 4 pi square E upon L by K square. Okay, so only difference is this factor of 4. So in this case, if we multiply this by 4, then we will get sigma C for both hands fixed at 40. Okay, so it will become, if we multiply it by 4, it will become 5058.16 Newton per mm square. Alternatively, you can also calculate it by keeping the values in the formula. 4 into pi square into E 2.05 into 10 to the power 5 divided by L by K is 40, so 40 square, or just multiply by 4. Okay, so you will get all the values. Here you will get, in case of both hands fixed, 1264.54. here you will get, if you multiply it by 4, then you will get 562.02. here also you can multiply by 4, here also multiply by 4. So like this you can get all the answers. Okay, so I hope you understood this problem. If you have any doubt, then you can ask in the comment section, and if you like this video, then please share and subscribe to our channel, and thank you for watching.